Independent variable is the factor that you change or control in an experiment. It is what you believe will influence another variable. For example, if you test how sunlight affects plant growth, the amount of sunlight is the independent variable. A dependent variable is the factor that you measure or observe. It is what you think will change due to the independent variable. In the plant example, the growth of the plants is the dependent variable. You depend on the independent variable to see how it affects the dependent variable. To understand the relationship better, let's consider a simple example. Imagine you want to know if drinking water helps students score better on tests. In this case, the independent variable is the amount of water the students drink. The dependent variable is the test scores of the students. You change the amount of water to see how it affects the test scores. If students who drink more water score higher, there may be a relationship between the two. Visualizing the relationship can also help. In a graph, the independent variable is usually on the x-axis. The dependent variable is on the y-axis. This setup makes it easy to see trends or relationships. In our water and test score example, you could create a graph showing the amount of water on the x-axis and the test scores on the y-axis. If the graph shows a line going upwards, it indicates that more water consumption leads to higher test scores. If the line is flat, it suggests that water does not affect test scores.
Carbon dioxide is released by humans. Around 30 to 40% is taken up by the oceans. The rest either remains in the atmosphere or is absorbed by the land. This causes oceans, which are alkaline, to become more acidic over time. Since the start of the industrial era, the overall pH of the world's oceans has fallen from 8.2 to 8.1. As oceans become more acidic, the number of hydrogen ions in seawater increases. Some types of coral have a hard outer skeleton made out of a compound called calcium carbonate. This compound is made of calcium ions and carbonate ions. Ocean acidification causes the amount of calcium carbonate in seawater to fall. This is because some of the carbonate ions that normally pair with calcium to form calcium carbonate instead pair with hydrogen to form bicarbonate. With less calcium carbonate around, corals find it more difficult to rebuild and grow their skeletons. This increases the chances of coral death.
Here are some key characteristics of whales. 1. Size. Whales are the largest animals on Earth, with the blue whale being the largest known species. 2. Adaptations for aquatic life. Whales have streamlined bodies, a horizontal tail fin called a fluke, and flippers instead of forelimbs. These adaptations allow them to swim efficiently in water. 3. Breathing mechanism. Whales are mammals, so they breathe air through blowholes located on top of their heads. They need to come to the water's surface periodically to breathe. 4. Diet. Most whales are carnivorous and feed on small fish, krill, squid, and other marine organisms. Baleen whales have baleen plates instead of teeth that they use to filter out prey from large amounts of water. 5. Communication. Whales are known for their complex communication systems. They produce various sounds, such as songs, clicks, and whistles, using their vocal cords or specialized organs like the melon in their heads. 6. Social behavior. Many whale species exhibit social behavior and live in groups called pods or schools. They communicate with each other through vocalizations and engage in activities like hunting together or caring for their young. 7. Migration. Some whale species undertake long-distance migrations between feeding and breeding grounds every year, covering thousands of miles. 8. Lifespan. The lifespan of whales varies among species, but can range from 40 to over 100 years depending on factors such as size and habitat. 9. Endangered status. Several whale species have faced significant population declines due to factors like commercial whaling, pollution, habitat loss, and climate change.
First off, we have the smallest Kemps and olive ridley. These species are known for often nesting in arabatas, which is when thousands of turtles come ashore to nest at the same time. The Kemps gets its name from the naturalists that discovered the species, and the olive for their olive-colored shell. Next, we have the hawksbill. This turtle has a very ornate shell and is unique to feed on poisonous sponges, but it does not negatively impact the sea turtle. They get their name for its hawk-like beak. Next is the flatback. This turtle only nests in Australia and resides in the Indian Ocean. They get their name from their flat-like shell compared to other species. All sea turtle species are on the IUCN Red List. However, the flatback is considered data deficient as not enough is known about their population to put them in a specific category. The loggerhead. They can be nicknamed a moving ecosystem for the amount of epibiota that can occupy their shells. They get their name for their large head, as they have strong crushing jaws for their diet that consists a lot of hard-shelled invertebrates. Next is the green sea turtle, the largest of the hard-shelled species. They are herbivores as adults, and as their diet consists of vegetation, their fat deposits are tinted green, which is where they get their name from. Lastly, our largest species is the leatherback, which can reach lengths of 7 feet and weigh over 2,000 pounds. They get their name for their leathery type shell that allows them to dive very deep in the ocean, accounting for those pressure changes. They have a diet primarily of jellyfish.
The word pinniped means fin or flipper-footed. Pinnipeds are animals that live in water but are able to come on land for long periods. The 35 living species of pinniped are divided into 3 families: true seals, eared seals which include the fur seals and sea lions, and the walrus. Seals do not have ear flaps, only ear holes. They have short front flippers and cannot rotate their hind flippers. Sea lions have ear flaps, large front flippers, and can rotate the hind flippers forward to walk on land. Tusked walruses have no ear flaps but can rotate the hind flippers. Pinnipeds face predation from larger marine mammals, polar bears, large birds of prey. They eat fish, shellfish, crustaceans, seabirds, penguins, and even other seals. A young pinniped is called a pup. Mothers and pups bond with a unique call. The Baikal seal is the world's only freshwater pinniped. Elephant seals are capable of diving over 2,200 yards or 2,000 meters deep. Walruses use their tusks to haul themselves out of the water and onto the sea ice, to keep breathing holes open in the ice, to fight with other walruses, and for defense against predators. When pinnipeds dive, their brain temperature drops by 3 degrees Celsius or 5 degrees Fahrenheit to reduce oxygen consumption. This extends a seal's diving capacity. Some seals can hold their breath for up to 80 minutes and dive as deep as 2,000 feet or 610 meters. Pinnipeds can sleep with half of their brain at a time to stay alert to potential dangers. The crab-eater seal don't eat crabs but use specialized teeth to filter Antarctic krill. Pinnipeds bark, roar and click.
The sights and sounds of a forest. Sunbeams slicing the darkness. The whistles and rustling of life surround you. Now imagine swimming through an underwater forest. Here, there are no trees. Instead, 150-foot tall seaweeds called giant kelp tower above you. Our national marine sanctuaries are home to magnificent kelp forests that host an endless variety of fish, invertebrates, and plants. Like trees in a forest, kelp can grow in dense stands, offering crucial hiding places that protect local residents from predators. But unlike trees, kelp can grow more than 2 feet a day. And it has no roots. Kelp grips the bottom with claw-like holdfasts that anchor it to the seafloor. Sea urchins, a common resident of the kelp forest, can chew through holdfasts, causing the kelp to lose its grip and float away. Normally, sea otters eat enough of the sea urchins to keep them in check, and the kelp forests thrive. But if sea urchin numbers get too high, they overgraze and destroy the kelp habitat, leaving a barren, deserted landscape. 4 national marine sanctuaries do regular surveys to track kelp forest conditions, understand natural cycles and human impacts, and protect these majestic towers of life.
Horseshoe crabs are often called living fossils because they were around before the dinosaurs. They are more closely related to spiders and scorpions than they are to crabs, thus, they are not true crabs. They have primitive gills that allow them to remain out of water for up to 4 days. They have 2 primary compound eyes, along with many secondary simple eyes. In the late spring and early summer, horseshoe crabs will crowd beaches in order to lay their eggs. This usually happens during the full moon at high tide. The female crab will partially bury herself in the sand and lay around 4,000 eggs per cluster. Over a course of a few days, the female may lay 100,000 eggs. Only a small amount of these eggs will survive. Any eggs that become exposed onshore are a major food source for migratory birds and loggerhead sea turtles. Eggs hatch within 2 to 4 weeks. The resulting larvae enter the water during high tide. Horseshoe crabs molt in order to grow. They reach maturity at 9 to 12 years of age. They can live around 20 years. Females grow larger than males. They can reach 2 feet in length. Horseshoe crabs use their tails as rudders in the water. They feed at night on things like marine worms, shellfish, and dead fish. In the winter, they can be found at depths down to 100 feet deep. Adult crabs are preyed upon by sharks, sea turtles, and birds. The blue copper-based blood of a horseshoe crab clots quickly in the presence of bacterial toxins, making horseshoe crabs very important to modern medicine. Medical researchers use it to test things like vaccines and medical devices to ensure that they are free of bacterial contamination. For this reason, horseshoe crabs are often pulled from the wild and drained of some of their blood before returning them to sea. According to an article in Scientific American, there are currently no restrictions on how many horseshoe crabs the medical industry can utilize. Researchers believe that returning these weakened crabs to the wild may be just condemning them to die. The numbers of horseshoe crabs are declining in many areas due to their popular use as commercial bait. Beach development threatens their spawning areas.